Alright, good job guys. We've gotten through a lot of material. We're going to continue our discussion of Math 090 material with factoring. Now, I wanted to remind you before we start factoring what we did in the last section. In the last video we multiplied 3x squared, a monomial, times a trinomial, x squared minus 4x plus 2. And to do that we distributed the 3x squared to each term in the trinomial. We did a little bit of multiplication and we simplified, and we ended up getting 3x to the fourth minus 12x cubed plus 6x squared. The question in this section, the factoring section, is can we reverse this process? Factoring is the reverse process of multiplying polynomials. So what we want to do is we want to start with 3x squared minus 12x cubed plus 6x squared, and we want to factor this and end up with the 3x squared monomial times the trinomial x squared minus 4x plus 2. We want to reverse the process of multiplication. And the way that we start doing this is we notice that each one of these three terms in this trinomial has similarities. For example, I could pull out, as they say, an x squared from each one of these terms. And I'll do it and you'll see what I mean. What we could do is we could change this 3x to the fourth into a 3x squared times x squared. We could change this negative 12x cubed to negative 12x times x squared. We could change this 6x squared to, well, a 6 times x squared. You notice that each term of our trinomial we were able to pull out an x squared. Now what we can do is we can do the opposite of this distribution that we did up here. In the previous problem we distributed the 3x squared to each term of this trinomial. Now what we can do is we can do the opposite of that. We can say, well, there's an x squared in each one of these three terms of this trinomial. We can pull it out. And what I mean by that is this. We could rewrite this whole trinomial like that. You'll notice then if we distributed this x squared to each of these three terms in the trinomial, we would get back where we started. So what we just did there was we factored out an x squared from each one of these three terms of this trinomial. But it looks like we can go a little bit further even, because each one of these three terms in this trinomial still has a 3 in it that could be taken out. So let's do that. I'm going to take a 3 out of the 3x squared term. So I'm just going to write it like this. I'm going to take a 3 out of the negative 12x term. So I'm going to write it like this. You notice what I did there. I changed the 12 into a 3 times 4. We can also pull a 3 out of this term, the 6th term here. When we pull a 3 out of that 6th term, we're left with the 2. So I changed the 6 into a 3 times 2. I changed the negative 12 into a negative 3 times 4. And I just rewrote the 3 basically. Now we can do the same thing that we did up here in this step. We did the opposite of the distributive property. We said there's a 3 in each one of those terms, so we can pull it out of the parentheses like this. Oops. Like that. We took the 3 from each term, we pulled it out of the parentheses, and put it out in front of the x squared. Now we'll notice that we're back to what we started with. All the way back here, the 3x squared times the quantity x squared minus 4x plus 2. That's what we ended up with. So we know that if we multiply this thing out by using the distributive property, we'd get right back to where we started. That trinomial right there. So this is our answer. We factored an x squared out of the trinomial that we were given. And we also factored a 3 out of that trinomial. And we ended up with the boxed answer. Why don't you try one on your own, just like it. Take this trinomial. See what you can factor out of it. hit pause on your video and come back and see how you did. So we want to factor 4x cubed minus 8x squared plus 2x. Now you can do this in one step or you can do this in 2 steps. I'll do it in 2 steps. You might notice right off the bat that each one of these terms has an x in it. What that means is I can rewrite each one of these 3 terms by pulling an x out of each of them. So I could write this first term as 4x squared times x. That's the same thing as 4x cubed. I could write the second term as 8x times x. That's the same thing as 8x squared. I can write the third term as just 2 times x. So we haven't done much here. All we've done is we've pulled an x out of each one of these 3 terms. Now we can use the opposite of the distributive property to pull the x out and write it like this. Just like that. Great, so that's the first step. Now go back to your trinomial. We've already factored an x out of this trinomial. Now we need to go back to this trinomial and see if there's anything else we can factor out. Well, there's not an x in this 2 term, so we can't factor out any more x's. But it looks like there is a factor of 2 in each one of these 3 coefficients. So what we can do is rewrite each one of these 3 terms with a 2 pulled out of it. 2 times 2 is 4, so we just rewrote this term. If I pull a 2 out of an 8, I get a 2 times 4. And if I pull a 2 out of a 2, then I just end up with 2 times 1. Now, since we've pulled a 2 out of each one of these terms, it looks like we can pull that 2 out of the trinomial, out of the parentheses. I'll put it right there. Then what we're left with in the parentheses is a 2x squared minus 4x plus 1. Great, that's your answer. If that's what you got, good job. As always, if you want more practice with factoring, you can go to the PDF file, 090.pdf, and there'll be a bunch of problems in that file for you. In the next video, we're going to be doing a lot more factoring. We're going to be factoring trinomials, and we're going to be factoring using perfect square factoring and difference of squares factoring. So I'll see you then.